Hello, and welcome to Train Signal. I'm Don Jones, and this is the Complex Conditions lesson in the Database Administration Fundamentals course. In this lesson, we'll mainly be working with the where clause of the select query. We'll look at operators, combining conditions, and several different predicates: in, like, between, union, and except and intersect. Most of the conditions we'll be examining in this lesson will primarily be a part of your query's where clause. For each one, I'll discuss what it's for, and then look at an example query that uses it. Keep in mind that these conditions can usually be combined to create very powerful filter specifications. SQL Server uses standard programming style comparison operators for its core comparisons: the angle brackets for less than and greater than, the equal sign for equal to, angle brackets for not equal to, greater than or equal to, and less than or equal to. These can be used with strings, numbers, and even with dates. For dates, less than means in the past, while greater than means in the future. Let's switch over to SQL Server Management Studio and take a look at some queries that use these basic comparison operators. I'll start with this basic query. Select all columns from the production.product table. Let's go ahead and add a where clause and specify that we only want ones where the make flag is equal to 1. You can see that column here, and it contains values 0 or 1. They look to be numeric, so I don't have to delimit quotation marks around my value. We can run this and just get back the products that meet that criteria. We can also change this to look for specific, say, stock levels, where safety stock level is less than 500. Let's see if we have any products that meet that criteria. And we do have a few. We have some with safety stock levels at 64 and so forth. So using these basic comparison operators with the where clause is pretty straightforward. Boolean operators allow you to combine multiple comparisons, and you've seen some examples of these in previous lessons already. The AND operator returns true if both of its sub-comparisons are also true. The OR operator returns true if either or both of its sub-comparisons are true. And the NOT operator simply reverses true or false. For example, where ID not in 1, 2, 3, 4 means that it will only select those columns where the ID value is not one of the values in that list. Let's go back to Management Studio and take a look at using these Boolean operators to combine query filter criteria. Now let's look at combining some queries using the Boolean operators. We'll start with the AND operator. I like to indent things so that all of my different comparisons kind of start at the same indentation level. That's why I put a couple of spaces before the AND. SQL Server doesn't care how you format these. This is just to make it a little bit easier for me to read. You'll even see some folks go all the way to the extreme of hitting tab so that they can line everything up real nice. And if you like the way that looks, then by all means go right ahead and do that yourself. So in addition to looking for a safety stock level that's less than 500, I want to look for ones that have a make flag of 1. We'll run that, and this shows me all the products that have both of these criteria set to true. By changing this to OR, you'll see the difference. Let's hit execute again. Now I have some products whose safety stock level is not less than 500, meaning it doesn't meet this criteria, but the make flag is 1, which means it does meet that criteria. I probably also have some that have a make flag of 0. So this was false, but they made it into the results because this was true. Their safety stock level was less than 500. You can also sort of reverse those around. For example, I'll throw the NOT operator in here. That just reverses true and false. So now it's basically the same as saying where make flag equals to 0. The in operator is kind of like an equality check, but rather than comparing a column to a single value, it compares it to a set of possible values, or, and this is the cool way to use it, to the results of a subquery. For a set of values, use a comma-separated list within parentheses. For a subquery, place the query within parentheses and ensure that it only returns a single column. An example is probably the best way to see that in action, so let's go to SQL Server Management Studio and take a look at the in operator. Let's say we wanted to get a list of all products whose safety stock level was either 60, 500, or 800. This query would certainly be one way to do that, where safety stock level equals 60, or safety stock level equals 500, or safety stock level equals 800, and that's what we got. The in operator lets us do that a bit more easily by simply specifying a comma-separated list of the values that we want and using the in operator. A little bit quicker, a little bit more concise, and a little bit easier to read. Frankly, I think it's also a little bit easier to update. If you change your mind later and decide you don't want 500 and you want 200 instead, it's a little easier just to go in and change this. If you want to add more values, well, that's certainly easier because you don't have to type another whole or safety stock level equals. You can just run it. Here's a cool trick too about Query Analyzer. I have two queries here in this window, and I'm not going to highlight either of them. Instead, I'm just going to click Execute. It'll actually run both queries and present the results in separate grids, one on top of the other. The like operator is used for wildcard string comparisons. Within the string that you want to compare to, use the % sign as a wildcard character. It can stand in for any 0 or more other characters. And keep in mind that string values are delimited in single quotation marks. Once again, seeing it in action is probably the best way to understand what it does, so let's go to SQL Server Management Studio and take a look at the like operator. You'll notice that our products table includes a product number column, and each of those starts with, well, it looks like most of them start with a letter. I just want to grab the ones whose letter starts with L. So we can use the like operator for that, where product number, like, single quotation mark because this is a string value, L, %, end quotation mark. We'll execute that, and we only get back the products that match. Remember, the % stands in for 0 or more other characters. So essentially, this is giving me everything that starts with L. Now, although SQL Server's command syntax is not case sensitive, meaning you can type select, from, and where in uppercase or lowercase, string comparisons, depending on the configuration of the server, can be case sensitive. Executing this query didn't give me any different results, so that tells me that this particular copy of SQL Server is configured for case-insensitive comparisons. The between operator specifies two values and checks to see if the specified column falls between them. For example, instead of saying where hire date is greater than or equal to the 1st of January 2000 and the hire date is less than or equal to the 31st of December 2009, you could say where hire date between those two values. Notice that this is a slightly different use of the keyword and. In this context, between the two values of a between operator, it is not acting as a Boolean operator. Let's see the between operator in action in SQL Server Management Studio. In my products table, each of my products has an assigned list price. I can see that a lot of these have a list price of 0, but scrolling down, I do see other values in here. Some of them are more than $1,000. I'd like to see a list of all the products that are between $1 and $500. So one way to do that would be to ask where the list price is greater than 1 and the list price is less than 100. That should return the results I'm after, but something of a more convenient way would be between 1, and 100. Scrolling over, it looks like all of my list prices are between 1 and 100. Union isn't exactly an operator. What it does is take two separate queries and combine them into a single result set. The number and the order of the columns must be the same for each of those two queries. And the data types for the columns must be compatible, meaning the columns either have to be of the same data type or implicitly castable into the same data type. The final result set will only include the rows that were present in both of the subqueries. For example, I have here a table that has 4 columns: first, last, depth, and hire date. I'm running 2 queries: select first and last from employees where department is shipping, and I'm unioning that. The second query is select first and last from employees where hire date is between these 2 dates. You can imagine how you could rewrite this query to simply use a single, more complex where clause, but this is also a valid way to do it. The results will include the first and last names of all employees who are in the shipping department and whose hire dates fall between the dates listed. This is definitely one we'll want to see in action, so let's go to SQL Server Management Studio and check out the union clause. Here's an example of a union in action. Notice that I've selected the same number of columns and that each of these columns has the same data type, and the columns have been selected in the same order. That was relatively easy to do because I'm querying both of them from the same table. The first query is grabbing all employees with a gender of M for male, and the second query is grabbing all employees who have a hire date between 1st of January 1990 and 1st of January 2011. Only those employees who show up in both lists will be included in the unioned results. And, here are those results. Sometimes if you've got something highlighted a little bit by accident, it'll take that as the query that you wanted to execute. That's why I got that error message. So you just kind of click and click execute again, and we got what we wanted. So this is a list of all the job titles of male employees who were hired between these dates. Now it's important to keep in mind that union can be used with 2 different queries that query different tables, so long as each query returns the same number of columns in the same order, and that each of those columns has a compatible data type between the 2 queries. Except and intersect are very similar to union in that they take 2 queries, but here they compare the results of those queries and return distinct values. When you use except, you get all of the results that exist in the first set that do not exist in the second. With intersect, you get the results where values of both of the queries match the query on both sides of the operand. The number and the order of the columns have to match on all subqueries, and again, as with union, the data types must either be compatible or castable. And these are definitely easier to see in an example. This is an example of the except operator. I have 2 products here. The first is the products table, which has a prod ID column and a description column. The second is a work orders table, which also has a prod ID column and a work order column. You can see that my 2 queries are selecting prod ID from products and from work orders. I'm using the except to combine the 2, so I will only get a list of products that do not have work orders. That would be product IDs 8 and 15. In other words, the 2 values that exist in the first query's results that do not also exist in the second query's results. Intersect is slightly different. Using the same 2 queries, select prod ID from products and select prod ID from work orders. Intersect is returning those values that do exist in both query sets. So you can see that 7, 10, and 27 are included in my results at the bottom of the screen. 8 and 15 are not included because they do not exist in the second set of query results. Now, just to prove that those really work like that, let's hop over to SQL Server Management Studio and take a look at accept and intersect in action. Here are my two example queries in real life. In this first instance, I have two queries that are each selecting a product ID column. The first is doing it from the work order, and the second is doing it from the product. Only those rows that are present in both query result sets will be included in the final results, which are shown here. I can highlight this and execute it by itself just to make that clearer. With the intersect, it's not that important that you be careful about what order your two queries come in, because only those results from both will be included. With accept, that's not quite the case. For example, here I'm again selecting product ID from work order and product ID from product. The accept will only include those rows from this table, which are also present in this table. And so if I run this by itself, I get nothing. That means I don't have any work orders. Well, see, this says products that don't have work orders, but that's not necessarily the case. You do have to be a little bit careful about order. Depending on exactly what your queries are, changing the order of these two can change the outcome. So if we execute this again by itself, not expecting to see anything, oh, there we go. Not expecting to see that empty result set again. So this is now listing all products that don't have work orders. Before, it was listing all work ordered products that didn't exist in the product catalog when I had these reversed. So with accept, it's very important that you get these in the right order. You'll get every row here that does not exist here. So depending on the type of data you're querying, you may get a very, very different outcome depending on the order of those two. In this lesson, you've learned how to build more complex conditions for your queries. We've covered operators, combining conditions with the Boolean operators. We've looked at the in, like, and between operators, and looked at how to combine query sets in different ways using union and accept and intersect.